Hello, I'm going to keep this one really short because there's not too much to say about this, but I got my parts from DigiKey the other day, including my TPS2024s. So if you haven't seen the previous video on switching from low side to high side switching, that's what I am doing with these here. And that is, in fact, this here. I've gotten rid of the N-channel MOSFET that I was using before for the low side switching, and I'm now using this part. I should be careful not to knock anything off the board here. For the high side switching, I still have my op amp there. And the other thing that I got in the mail is this cool switch, because I was looking at different switches. By the way, one thing to keep in mind, if you're ordering stuff from DigiKey or Mouser or something like that, this is kind of what happens if you don't pay attention to the sizes of things when you buy them. Because I was trying to think what sort of a push button would I want to have to be able to, switch it on quickly. And so I got an assortment of different things. I got this kind. But yeah, I thought maybe I want a red button, but I didn't really pay attention to the fact that these are huge. They're probably going to be larger than the box this whole thing goes in. Also some capacitors too. I was looking to get a few capacitors of this style, and I ended up with these. So yeah, pay attention to the physical dimensions. Anyway, back to the point here. This is now all hooked up. I have rebuilt this around the TPS2024, and also this switch, which has a built-in bicolor LED. Well, it has two LEDs. There's a red one and a green one, and the way they're hooked up is they're alternate polarity. So if you power it one way, you get the red. If you power it the other way, you get the green, which is not super convenient for me because that's not the way I designed this thing to work. So I had to figure out how to do that, and that's where this was going to be a short video, right? I wasn't even going to talk about this, but I just remembered. This circuit sim thing here, which I signed up for because it's it's like $15 for a lifetime membership. Really liking this for playing around with different stuff. So what I needed to figure out was, here is, for example, my two LEDs. I've got the red one going that way and the green one going that way. And what sort of an arrangement could I use so that only one of them is powered at a time? And this switch over here is a stand-in for that TPS2024 chip. It can either switch 5 volts or ground into here. And then it occurred to me that it's kind of serendipitous, because the LM358 dual op amp chip, where the other day I used only one of the op amps, I freed up the other one, and this circuit here uses the other op amp conveniently. I thought I was clever coming up with this on my own, and then I realized it's just an inverter. There's nothing clever going on here. But what happens is this gets, well, I can actually run the simulation here. So this gets a volt-ish in on the non-inverting input, and then the inverting input is just the output of the power switch, which also goes to the other end of this bicolor LED arrangement, so that if it's getting 5 volts, then this comes back around here, turns this off, so that we got +5 on one end and ground on the other, and vice versa. If this is going to ground, then this turns on, so that you got +5 over here and ground over there. If I didn't just say that backwards. So when I switch this, what happens is the color one LED, the red one goes off, the green one goes on. So that does exactly what I want. And I was able to, when I thought of that picture and drew it on the whiteboard, then I was able to draw it in here and confirm that it does in fact work the way that I thought. And I can see all the values here of how much current goes through and stuff like that. So let's see it working. I'll just turn on the power supply. It'll be the same thing as before. There will be a threshold voltage, and this will rise up to the threshold voltage as the capacitor charges, and then it should turn on the device that's connected to the USB port. But the other thing that we'll see this time, so when I turn this on, I get a red light here, and that's doing its charge up thing. And when that green reaches the yellow on the oscilloscope, the device should come on, and this should also switch from the red LED to the green LED. Hopefully everything will go as planned. Voila. So Oh, that's kind of cool. So this is kind of what it'll be mounted in the, in the box, so that you'll be able to see that it's on, and you'll also be able to see what state it's in. If I just reset this one more time, because this is also a push button, it has double functionality. It shows the current state, but you can also press it if you don't want to wait and have everything turn on right away. So kind of nice that that part was sitting there waiting for me to use it. And so yeah, that's pretty much the whole thing. The only other, of course, I still need to build it into the circuit board, and it won't have one of these goofy little trimmer pots. I'll have an actual physical knob to set the threshold. And yeah, I got some USB ports to put on either end. So I'm just going to keep talking if I don't stop now. So I'm going to stop now and upload this. Hope you found that somewhat interesting, and we'll continue along the journey as I continue to build this into a finished product. If you're not already subscribed, would love it if you did subscribe to my channel. My device over there says I have 3,070 subscribers. So I'll see you in the next one. Bye.